Alright, so today what we're going to talk about is how to find the area of any regular polygon. So our first example here is a pentagon whose side length is 10. Now, inside the pentagon, we only care about the triangle that is formed within the vertice to center. Okay, there are 5 of those, but we really only care about one of them. And so what I want to talk about is kind of how we're going to do all of these problems. The easiest way to do this is to just focus on a triangle. And what I did is I pulled this triangle out so that you can see it. I'm going to put some things on this triangle. I'm going to put an R here, an R here. I'm going to put an S here. I'm going to draw a dotted line splitting this thing into half. That's what I'm trying to do here. And I'm going to put an A here. And then this whole angle right here is going to be the central angle. Okay. So we're going to talk about all that. Okay, so this is the central angle. This R refers to the radius, okay? This A refers to the apothem, and this S refers to the side length, because it's the side length of the polygon, right? So the A is the apothem, the R is radius, the S is side length, and then this is the central angle. In order to find the area of any polygon, we have to find its apothem, and we have to find its perimeter. So to find its perimeter, we have to know the side length and the apothem. Now sometimes we're given a part of that, and sometimes we're not. But we have to figure out what we're given in terms of every particular problem. Okay, so I'm going to do one of each of those for you today. All right, so this problem, I'm given the side length. So that means I'm given this bottom piece, right? Which happens to be 10. So that means inside of my triangle, I have a bottom piece of 10. Now, the first thing that you want to do is you want to find the central angle. So every time you do one of these problems, you want to find the central angle. So to do that, you're going to take 360 degrees, and you're going to divide that by the number of sides, n. So 360 over 5, which in this case is 72. So my central angle is 72. Now, you're going to want to divide that by 2 because you're going to want to split this into 2 right triangles. So that's 36. Because I can use trig then to help me find all the parts of this triangle. Alright, so the first thing we do is we draw an isosceles triangle, we find the central angle, okay, and then we split it. And then we place what we know on this figure. So let me redraw my triangle now with what I know. So here's 10. I don't know what A is. I know that this part is 36, and that's all I know. Okay, so I know my side length, which will allow me to find the perimeter, right? So let's go ahead and do that. So the perimeter is going to be equal to 10 times 5 because it's 5 sides, right? So 50. So far in this formula, I know the perimeter. I do not know A, so I'm just going to leave that blank on here. So we don't know what A is, but we do know the perimeter is 50. So we're going to go ahead and put that in there. Alright, now using my triangle, I can actually find A, which is my apothem. So if you look, this is splitting this in half. So that means this is 5 and this is 5. So now I have a right triangle. So let me draw a right triangle for you. We have a right triangle whose one angle is 36, whose bottom is 5, and we need to find the apothem. Now using trig, we can do that. So if we look at 36, we know that this is the opposite, and we know that this is the adjacent using trig. So that means using SOHCAHTOA, I can do the tangent of 36 equals the opposite, which is 5, over A, which I don't know, right? Now I can cross multiply like we did back in module 8, and we're going to do A tangent of 36 equals 5. I'm going to divide by the tangent of 36. And so this is what I'm going to put in my calculator. So 5 divided by the tangent of 36, making sure that my calculator again is in degree mode. That's going to be approximately 6.88. So that means that my apothem is 6.88. All right. Well, that helps me because now all I have to do is put that into my formula right up here and then multiply. So 6.88 times 50 divided by 2 or multiplied by half gives you 172. And since we were looking at inches, I believe we're going to do inches squared because that's our area. So all we got to do is find our apothem and our side length so that we can find our perimeter and our area. So let's go ahead and look at another problem. All right, for this problem, we're going to find the area of a hexagon. This time I don't have it drawn. I'm just going to draw my triangle. A hexagon we have to know is 6 sides. That helps us. Okay, so our formula is area equals 1/2 apothem times perimeter. Inside this thing, we know the radius. So remember my template from back here. Our template had R's, S, A, and our central angle. So since I know the radius, I know these side parts. Okay, I do not know the apothem, and I do not know the side length, both of which I need to be able to find the area. So what I want to do first is find the central angle. So the central angle is found by doing 360 divided by 6 this time, right? So 360 divided by 6 is 60, and then you're going to divide that by 2 so that you can get both of these pieces, right? This is a 30, 60, 90 triangle, but I'm just going to use trig to try to help you out because I think trig's easier to use than those templates sometimes. All right, so let's pull the right triangle out and let's look at what we know. So just looking at this side of the right triangle, we know I have a 30-degree angle, I have 14 as my hypotenuse, I have this 90-degree angle, and I'm actually needing to find both of these parts. So really, for me, it's just finding one of them. It doesn't matter which one. Personally, I'm just going to go ahead and find A. Maybe that's what you want to do every time. That'll be fine. So using 30, A is my adjacent, 14 is my hypotenuse, which means I'm going to use the cosine. So the cosine of 30 is equal to the adjacent over the hypotenuse. So when I cross multiply, that will become 14 cosine of 30 equals A. So I'm going to go ahead and put that in my calculator. Again, degree mode. 14 cosine of 30 is equal to 7 square root of 3. Now I'm going to go ahead and round that because some of y'all won't have that. So we're just going to go ahead and say A is going to be equal to 12.12. Okay? So that tells me what my apothem is. Now that means in my formula, I know the apothem. The apothem is 12.12. I still don't know the perimeter because I don't know the side length, right? So I need to find that side length. The easiest way to probably do that is just to use the Pythagorean theorem because you're used to doing that. So this is 12.12 here, so I can do a squared plus b squared equals c squared. So using the Pythagorean theorem, a squared plus b squared equals c squared. I'm going to go ahead and say 12.12 squared plus b squared equals 14 squared. Okay, so 12.12 squared is 146.89 plus b squared is equal to 14 squared, which is 196. Scroll down just a little bit. I'm going to subtract 146.89 from both sides. So that means b squared is going to be equal to when I subtract those 49.11, and then I have to square root. So that's approximately 7. So my side length is approximately 7. Now remember, this is not really the whole side, right? This is only half of the side. So since I know this part is 7, then I know this part is 7, which means I know it's 14. So the whole thing is 14, which makes sense because this is an equilateral triangle in this case. The reason why it's equilateral is because I have one angle that is 60 and two of my sides are 14. Therefore, these two down here have to be 60 and this has to be 14. We did trig just to check it. That only works on a hexagon. So a hexagon will produce equilateral triangles. But using trig, you can find to make sure. All right, so I know that 14 is my side length. I still need to find my perimeter, right? So let's find that perimeter. Perimeter is going to be equal to 14 times the amount of sides, which is 6. So 14 times 6 is 84. So my perimeter is 84. All right, let me go ahead and scroll back up and let's put that in there. So let's put that in my formula. So my perimeter is 84. We'll put that right here. So 84 times 12.12. And then we're going to divide that by 2. That's 509.04 inches squared. Okay. All right, so we did one problem where we had the side length. We did one problem where we have the radius. Now we'll do a problem where we have the apothem. So we're going to find the area of a regular heptagon. Heptagon has 7 sides, whose apothem is 5. So the first thing we do is we find our central angle, so 360 divided by 7, which is 51.42. We're going to go ahead and divide that by 2 because we're going to need it, right? So 25.71. So 25.71. Our apothem is 5, so that means this is 5. So when I go ahead and pull out that right triangle, I have my angle, which is 25.71. I have my apothem, which is 5, which is great because now I know my area. I know part of it. I know my apothem, so I can go ahead and place that in there. So 1/2 of 5 times the perimeter, which we need to find. So to find the perimeter, we have to just find this bottom piece, right? So we only have to find that one part, which is down here. Okay? So to find that part, we're going to use trig. So using that angle, I have the opposite and the adjacent. The opposite and the adjacent is going to be the tangent. So we're going to do the tangent of 25.71 equals the opposite over the adjacent. So that means 5 times the tangent of 25.71 is equal to x. So 5 times the tangent of 25.71 is equal to 2.41. So that means that this part right here is 2.41, which means that that's only half of my side, right? So that means I gotta double it because that's gonna give me the whole thing, right? And so 2.41 times 2 is 4.82. Now that gives me one side, right? But I have to find that perimeter, right? So to find that perimeter, I do 4.82 times the amount of sides, which is 7. So that's our just language. We have to know what heptagon means so that we know how many times I have to multiply that. So 7 times that is going to give me 33.74, which is my perimeter. And I'm just going to go ahead and place that up here. So 33.74 times 5 divided by 2 is going to be 84.35. And again, we don't have a unit here, so we're just going to do units squared. All right, so it's easier always just to use that template that I talked about. You're always going to have to do trig unless you know everything. So it's just kind of using that central angle to help us. So always find your central angle first, figure out what you know, figure out what you need to find so that you can go ahead and then plug it into the area formula.